The following table shows fuel consumption in billions of gallons of all vehicles in the U.S. for years since 1990. Looking at the table, the first column gives the years since 1990. The second column gives the fuel use in billions of gallons. Let F of t be the fuel consumption in billions of gallons in t years since 1990. A quadratic model for the data is provided. Notice how we also have the scatter plot and a graph of the given quadratic model in black. In the first question, we're told to use the scatter plot to determine whether the quadratic model fits the data well. We normally use the value of r squared to determine whether the model fits the data well, where the closer r squared is to 1, the better the model. But in our case, looking at the scatter plot, notice how the black function does model the behavior of the scatter plot well, and therefore we will say the function is a good model for the data. Next, we're asked to estimate the fuel consumption in the US in 2015 in billions of gallons. Well, remember t is the number of years since 1990. To determine the value of t for the year 2015, we take the desired year of 2015 and subtract the base year of 1990. 2015 minus 1990 is equal to 25. To make our prediction, we use a t-value of 25, which means we need to evaluate the function at t equals 25 or determine f of 25. F of 25 is equal to negative 0.114 times 25 squared plus 4.62 times 25 and plus 127.598. If we go back to the table just for a moment, because all the fuel consumption numbers have one decimal place, we will round this function value to one decimal place. So going to the calculator, we determine the function value. To one decimal place, the function value is approximately 171.8. Which means the fuel consumption estimate for the year 2015 is 171.8 billions of gallons. Next, we're asked to use the model to predict the year in which the fuel consumption will peak. We're looking at the graph of the quadratic function, or noticing that a, the leading coefficient, is negative. We know we have a parabola that opens down, and therefore to determine when the fuel consumption will be a peak, as well as what the maximum fuel consumption would be, we need to determine the vertex, this high point. And because we have a function of t, the t-coordinate of the vertex is equal to negative b divided by 2a, and the corresponding function value is f of negative b divided by 2a. Notice for our quadratic function, a is equal to negative 0.114, and b is equal to 4.62. So for the vertex, the t-coordinate is equal to negative b divided by 2a, which is negative 4.62 divided by 2 times a, which is 2 times negative 0.114. And now let's go back to the calculator. We have negative 4.62 divided by, and then in parentheses, 2 times negative 0.114. Enter. So notice t is approximately 20.3. So this is the value of t, but we are looking for the actual year in which the fuel consumption will peak, not the value of t. Remember, t is a number of years since 1990. So if we take 1990 and add 20.3, notice how that gives us 2010.3, which means this is 0.3 years after 2010, which means it would be in the year 2011. So the fuel consumption will peak in the year 2011. If this is confusing, remember if t was exactly 20, we would have 2010, meaning the end of the year 2010. So because it's more than 20, it pushes us into the next year, which would be in the year 2011. I hope you found this helpful.